This video is for introducing the main operating interface of GHBM-700T controller. First of all, you can see this button is clicking for login. You can input the username and password for getting more permission of the controller. This button is for switching the bandit step. 1, 2. This button is for switching to the programming list. This button is for turning into the I/O page. You can check the signal input and output situation in this page. Also, you can hold on this button. You can see there is a number 1 showing in the middle of this button. That means the machine will return repeatedly band on this banding step only. And you can hold on this button to cancel this mode. And this is the product name. And this is the material choosing. You can select it, the correct material in this page. And this is the material thickness. You can input the material thickness in this by clicking this button. And this is the compensation area. The compensation value on the left side is the overall compensation value, and the value on the right side is the single banding step compensation value. That means this compensation value only for number 1 banding step. And we can see this button, click, and you can select it, the banding mode. The first is air band, precision band, bottom band, and harmony band. And this is the angle that you want. You can input it 90 degree that you want. And this button is for choosing the x-axis measuring method. You can select it, outer size, inner size, and x-axis actual moving stroke of the x-axis. And this is the value that you want to programming. 200, then okay. This is the r-axis. That means the baggage up and down motion. And this is the crane system, that compensation on the workbench. This compensation value will be calculated automatically according to different material thickness and different material banding length. See, if I change it to 200, then it turned to 0. Okay, then let's turn to the right side. This is the programming value will be used. This button is for the yield function of the x-axis. You can see there is 20 millimeter. That means when the material was pinched by the punch tool and the die tool, the x-axis baggage will back pull for avoiding the scratch between the stop finger and the material. And you can see there is a switch here. that means the weight. When this switch is turning off, the back pull of the x-axis and the y-axis dropping, they will persist together. If I turn on this switch, the y-axis will keep on the same position, and then the baggage will back pull until it back pull to the target position, and then the y-axis started to drop and bend an angle on the material. This is the mute disc. That means when the punch tool there is 2 millimeter to the die tool, then the y-axis will turn into the slow speed mode. This is the dwell time. That means the y-axis will keep such a pressure on the material for 0.1 second, and you can edit the dwell time too. Maybe you can edit it in 1 second, because there is spin back on the material, so that sometimes we need to add the dwell time to make sure the spin back is less. This is the opening stroke of the y-axis. After this bending step is finished, how much stroke should the y-axis rise for the next bending step? And this is the repeat times. How much times you want to repeat this bending step? You can input here, and then you can see there is an error here. There is other values that they are used not so often. This is the pinch point offset value. When you find that the material cannot be pinched by the punch tool and the die tool, and you can make it minus 0.2. When this value is minus, the y-axis will drop more to press on the material, to pinch the material. And this is the position offset. This function is for when you want the y-axis not dropping over the die tool. You just want it to stop higher than the die tool, and then you could input a value here. For example, when we input 20 millimeter, then the punch tool will stop 20 millimeter over than the die tool, and it won't drop anymore. This is the bending speed. The slow speed of the y-axis. When the y-axis turn into the slow speed, how much speed you want it to work. 100% is the maximum speed, and you can make it smaller, 50%. Then the y-axis will drop slower in the slow speed mode. This is the ram's rising speed, the y-axis rising speed after the angle bending is finished. This is the ARC angle bending function, and this is the delay time this is the delay time between bending steps. For example, when the first bending step is finished, if I make it 5 seconds, the baggage will will move to the position, the target position after 5 seconds. This area is the y-axis target position and actual position, same as other axes. And this value is calculated according to different programmed angle. For example, 120 millimeter. It is calculated according to the angle. This is the status bar. It shows all kinds of alarm of the machine. For example, the X-axis alarm, Y-axis alarm. This is the status bar 2. It shows the working step of the machine. For example, if we show the X-axis position step, Y-axis approaching status, and slow speed status, and also the returning status. Show the standard bending operation step is, firstly we turn on the machine and then start the motor until this light is showing green, and then we click this reference button. Make sure the slider is roughly horizontal. That means you need to inspect if the Y1 and Y2 is in roughly horizontal level, and click OK. The Y-axis will read the reference point. Also the X-axis will read the reference point until this button is showing green color. Run. Then you can start the bending operation.